Okay, so arithmetic series is our next bit. We looked at arithmetic sequences. So that's just the sequence was just a string of numbers. Sorry, I'm just flicking back a little bit. So with the sequences, can't find a nice example just when I want one. Probably have to go right back to the beginning. So sorry about that, people who are listening. So, right, notice it's just a string of, whereas what we're doing now is we're going to be adding those terms together. And most of them have a finite n, so it's add them up until the 5th term or the 6th term. And with arithmetic, that's what will happen. When we do our geometric, what could happen is the same thing. It goes finite, or it could be that it converges to a certain point. But that's a story for when we do geometric. So you don't have, oh sorry, and you've already started copying, I apologise. This was just for your FYI, all of that. The main thing are these two equations. So sorry, whenever you have a slab of something, never have to copy the whole thing, you note take. So you read, you go, yes, I understand, but the formulas are the main ones that you want. Now the terminology, you've got to be careful, I'm coming, the terminology you've got to watch for. So as soon as you see SN, that is you going, this is a series. In other words, this is you working out if I add up so many terms. Add up a whole lot of terms, okay? The N, the A, the D, same as what we had in our formula for an arithmetic sequence. The general term of an arithmetic sequence was Tn A plus N take 1D. Same that apply. N is the nth term, right? N is for the number of terms that you go up to. A still is your first term. You can also see it written as, how else can we write our first term? T1 all over it. And D is our friend, the difference. So nothing new to see here apart from SN, that means you're adding up the terms. TN, you're just finding what term it is. Make sure you don't confuse the two. Okay, so a little bit of a, yes, oh sorry, I should, an A first term and L. Anyone want to have an idea what L would be? Last term. So that was the only new one that we had to put in there, the last term. And that is a cursive. That is a cursive L. Why do you think we have to do a cursive L? Yes, so you don't mix up. If you're going L, that looks like a 1. So fancy pantsy, just do a little bit of a, oh, L. Nice, curve. Bit of a yarn. Teacher has an annoying student in the class. They decide I'm going to keep them busy. So go away. Go and add up all the numbers from 1 to 100. Student in a couple of seconds did a little bit of on the paper and bang, got their answer. Teacher was astounded. How did you do that? Well, I want you to think about all the numbers from 1 to 100. Is anyone without using the formulas at the moment? I'll just have a look down here. So if we've got 1 plus 2 plus 3 plus 4 and we keep on going. And we want to go all the way to 100. What would be the term before 100? And so on. So the student noticed a pretty interesting little thing. And they went, well, I just simply took the first term and I took the last term, added them together. What's that? 101. Then I looked at the second term and the second to last term. What's that? 2 plus 99. Then I took the third term and the third to last term. What do you get? 101. So how did they then work out adding up all the numbers from 1 to 100. So quickly, all they had to do was times 101 by 50. And fooled around, they kept doing this over and over again, and lo and behold, that's why that formula works. They're taking the first term and the last term and timesing it by half of the numbers that you have. Well, why do we have to have 2? Why do we then have to have 2? It's about the information that you have. Okay? We could spend a whole lot of time playing around with this and then going, what happens if you don't have an even lot of numbers? What happens if it's an odd lot of numbers? Because when you times it, you divide it by 2, there's 1 left over. It still works. What happens if you're not going up by 1 all the time? What happens if you're going up by 3 or by 4 or whatever? It still works. It's just freaky. Sadly, we have to dive in and trust. You have to trust me that these formulas work. Is that okay? But that's so cute. People just discovered. Anyway, you don't seem that impressed. I was impressed. Do you want to do it with 3s? Right. It's jolly good. So what if we went 3 plus 6 plus 9 plus 12, right? And we could go up to something that's divisible by 3. So you could go 9, 9, 9. What's 3? I should have gone 81, shouldn't I? Let's just go 99 then. 99, right? What's 3 before 99? What's 3 before 93, right? And again, go through, and what's the first term and the last term? This time it is 102. But now, when we go the second term and second to last term, what's 6 plus 96? It's 102. What's 9 plus 92? It's so cute. It's just, you know, and if you look at the formula, for your, it sort of makes sense where you're going this plus this, they cancel each other out, and that's how you actually end up with B. If you put it in as A and then A plus, they all cancel out and you're left with those formulas. So it's a hootenanny. All right. Now this is a take it or leave it, and don't get too alarmed. And I'm just telling you this because if you open your Hazy textbook, you might see this notation. And I'm hoping that you might have seen it before, especially if you're a lover of spreadsheets. Capital Sigma, Greeks, very important in mathematics, but this is capital Sigma, and it means the sum of, right? The sum of everything, right? It's just the sum of numbers. So if I wanted to write the sum of these numbers, we would go, it's just n, and then we would have the n can start with 1, and then it goes, or it could be, so bad me, k, and then k, and k goes all the way up to n. If I only wanted the sum of the numbers up to 20, then I'd say here, stop at 20, so on and so forth. If I had, it was instead of k, it was k squared, then that sum would be 1 plus 4 plus 9 plus, and so on, okay? So don't be alarmed if you see those things when you look at the Hazy textbook. They are not in the Cambridge, but so relax. They just pop up every now and again. You go, oh, what's going on? So let's do a couple of questions. How will we know which formula to use? Well, it depends on the information you're given. If you're not given the last term, well, you're not going to use the right-hand side formula. Correct? Okay. Are we all good, or did people want to write the... If you were writing this down, we've got our formulas already. For this one, you could, in your note form, you would just go 2 plus 5 plus 8 plus 11. Do you really need to say that it's an arithmetic? Well, we can see that it is because it's got the same difference. And we want to go all the way up to the first 14 terms. So I'm going to write down my information. I want to see n, would we agree, is the 14? I do not have my last term, so that's a making sure you read. It's 14 terms. It's not saying the last term is 14. This is saying it goes up to T14. Does that make sense? So we know n. Do we know anything else? We absolutely know A. A is 2. And we know one more thing. We know the difference. Okay, and a reminder, when we do ratios, hopefully we get to that today, remember it is always the second term take the first term. 5 take 2 is 3. It's really important, especially when negatives are involved. If you went 2 take 5, you get -3, that's no good. Okay, so little reminders. So we're going to go all the way up to the 14th term. Okay, so calculate the sum of the 14 terms. We're not going to use this formula. We're going to use this one because we've got the N, we've got the A, we've got the D. We've got everything we need. All we do, S14. You know, I'm a fan of writing the formula because then you don't have to keep going and looking it up, but it's right above me. That's why I put it there. So we sub in 14 over 2. So what is it that we're getting from this? I don't think this is actually hard mathematically. You're just subbing numbers into a formula. Year 8s can do that. It's reading the question, knowing how to write down the information that you get, because when it gets more complicated, you don't have to worry about all the words. You can just see your information hither and thither. So getting into good habits will make your work a lot easier. All good? Okay. Look at 14. Keeping in mind, these questions are going to be mixed up. When we do the geometric, you've also still got sequence questions. So we're looking and we go, find the sum. So as soon as we read sum, we have got these on our formula page, your page of notes. Okay? And now we look and we go, what information do we have here? Yes, so we're reading here, it ends. And so what can you tell me that 141 is? It's the last term. So we're looking, we can get a few things. We've got A equals -6. Have we got the common difference? What is the common difference? Positive or negative 7? Good. 1 take 6 becomes 7. 8 take 1, so it's 7. Okay, and we also know that L is 141. And we go, oh, fantastic, this is easy. Let's just go over to the second formula. Let's just sub it all in and O. Why O? I do not know what N is. How are we going to find N? Well, you can do this quite easily from the stuff we did before. I'm just going to scroll down now. Okay, so as I said, we immediately want to go, oh, Sn equals, I've forgotten, n over 2, n over 2a plus. That would be great because you've got your last term, but unfortunately, do not know. But because we've got A and D, can't we go back and use the stuff we did before where we have, I wanted to change colour, please. T, N equals, what was it, remember? A plus, and you're going, oh, Maccas, what's going on here? There's still an N, and that's what we don't know. Well, that's what we're going to find, and we're going to use that to find it. Because we know the A, that's -6. We do not know the N. We know the D is 7. But we have this term and we know that it is 141. We have a term, and what we're going to do is we're going to use this. We could now find out what the nth term is, isn't it? Let you digest that. So now that we have n, we can now substitute everything in there. So we can get the sum is 22 over 2. A is the minus 6 plus your last term is 141. And there you have it. What changeover do we have? All right. And last one before I am quiet. So one more example of how they're going to give you different information and how are you going to find what you need. So have a read, bit of information that you want to write. Big D. Excellent. So we've got A is 3. And by the way, as soon as I have read this and it's got the sum, I'm straight away looking at these two formulas. I don't know which one I'm going to use at the moment. I'm going through. Okay, what else? I mean, A and I've got D. Yep. What's D? 6 take 3. Beautiful. And the sum of the first 25 terms. I've got N is 25. So that is clear cut. We're just going with formula numero uno. Let's have a look at part B. Calculate, bless you, calculate the number of terms. So again, what am I trying to calculate here? What am I, yeah, no, thank you, number of terms. What should I put? Good, N equals, so we're trying to find N, and this time we know that Sn, so the sum of all the numbers, is 1,395. So whichever formula we use, we are going to replace this or this with 1,395. So I might even write that if I'm reading this question. I mean, I can underline it, but if this is you writing in your book, you're putting down again all your information, so then it's, you're not even thinking, you just sub it where it's meant to be. You're not going to accidentally put 1395 where N is meant to be because you said it's not N, it's Sn. Okay, so where shall we put it? Yep, in the first one, because we've got the A, we've got the D, and we'll have this one, we're going to try and find N. So just a little bit of algebra. Why, I mean, it would have been nice if we could do the right-hand side one. But we don't know. Okay, you've got options. If you wanted to, you could find out what the last term is, but I reckon just slap it in. So here we go. 1395 N over 2. 2 times A, so happy that I've written 6. Yeah. Plus N take 1, N is 25. Oh, no it's not. We don't know what N is in this case, that's what we're trying to find. So it's N minus 1 times D, which is 3. Now let's just play around. For some of you, you might be going, I'm not a fan of this divide by 2 here. The fraction is irritating me. Well, let's get rid of it. How do I get rid of a divide by 2? Times by 2. Six take 3. Last time I checked is 3. Oops. N 3. Plus 3n, a friend of yours is coming to town. Who's our bestie? Who's our friend when we expand that bracket? No, quadratic. So we're going to have a quadratic when we expand this to 790 equals 3n plus 3n squared. We're going to go, sweet, thank goodness I have my trusty calculator. If I did not have my trusty calculator, I'd groan a little bit. I would ask and check, is 3 a common factor? And I'd pull that out first. But quite frankly, I don't need to do that because we've got on our calc the polynomial solver. Yeah? Okay. Okay, so into your calc, into equation, polynomial, degree 2, it's going to be 3, was it 3, 3 or 3 minus 3? 3, 3, and minus 2. Oh, your memory is jolly good. Now, our two values for n are 30 and minus 31. Am I writing them both? No. What was the thing when we did this right at the beginning? N has to be positive integer. Excellent. So we would then say, therefore, n is 30. Obviously, there's going to be different ways that they can word it, different order that they can give you the information. But if you do that, put down the information that you're given, A equals D or L, read it clearly. Put down Sn. You have it or you're trying to find it. And you've got those two equations. Plus, keep that little general term for a sequence, arithmetic. You're going to be good to go. Yes? So what I'm going to ask you to do, if you haven't finished up to question, I think it was 18 of your Cambridge, or you've got some questions, do that. If I can't get to you immediately and you're waiting, don't sit there and do nothing. You may start 15C, sequences and series, because I think that's pretty good. Please don't waste your class time because I want to start geometric sequences as well. I'll save this for you on OneNote. There are a lot of different types of sequences. Boys, eyes this way and ears this way. We're looking at 2 and 2 only, arithmetic and geometric. We've done the arithmetic, now we've got the geo. So the geo is that they are having a common ratio, one divided by the other. So like we did with sequences, to find the difference, we went one term, subtract the term before it. We do the same thing with geometric, except instead of subtracting, we divide, okay? So all this is saying is here, for me to find the common, instead of common difference, it is the common ratio. Ratio, Horatio, and we call that R. Look at our formula. It's even nicer. It's simpler. It's simpler than the arithmetic one. Easier, less involved. So how do I get my A? Look at that, first term. You already know this, don't you? How do I get my R? Well, it's 4 divided by 8. What is 4 over 8? 1 over 2. Double check the next lot. Is 2 over 4 a half? Is 1 over 2 a half? Yes, yes. So for this, you can easily go, not a problem. A is 8. The ratio is a half. And then you slap it into your formula. Bang, we're done. And then you just sub as you go. So those who are scooting along and get to the end, or if you get stuck with 15C, do not down tools and say, I'm done. Make your 40 minutes solid and you can start the geometric sequence. I thought I'd get a little bit further into it, but really, you've made a good foundation at the moment where you can go a little bit further. Wait. Keeping in mind, what's a different way of writing 1 over 2? 2 to the minus 1, not 2 over 1. 2 over 1 is 2. 2 to the minus 1, some people might write it like that. Psst. So, please, 40 minutes, start geometric sequences if you have finished and you're happy with the series. If you only get to finish the series, that's okay as long as you've done at least 40 mins. Everybody clear?